I wanted to conclude with some discussion of the possible directions for future work. One possibility we explored in this work was combining unsupervised finite state and neural models. And the intuition here was that the strengths of the two model classes are so disparate that together they can prevent each other from straying too far from the ground truth. We tried some simple test time combinations. Unfortunately, they didn't really work, but I still believe that combining them is the right way forward for decipherment-like problems. We just need to combine them in a smarter way. We could, for example, do the joint decoding at training time as well, so that the models can learn from each other. Or we could structurally integrate the desired properties of one model into the other. For example, there's a whole line of prior work on encoding structural constraints like monotonicity into the attention mechanism of the sequence-to-sequence models. Another line of work considers using neural parameterization for finite state models. We could also try to bias one model towards behaving like the other. For example, we could decode with one model and then pre-train the other one on the predictions of the first one. And as I said before, there is this trade-off between power and structure. But with our neural models becoming more and more powerful, maybe they can be, powerful enough that we wouldn't need any structure at all. For example, Shiji Wu and colleagues trained their transformer to perform character level transduction tasks without this explicit structural bias, and it actually outperforms their previous structurally constrained models. But so far, this also seems to be a function of the amount of labeled data. So this result for the transformer was obtained in the supervised scenario, and unsupervised for unsupervised or low data tasks, structure is still likely to be crucial. In the second direction I wanted to discuss is paying attention to user preferences. First of all, users tend to be consistent with their substitution choices, probably for their own convenience. Like if I Romanize Russian V as Latin V, I'm probably going to do that with every occurrence of the letter V in my Russian text. There can also be larger stylistic patterns, like some people have a tendency to use visual substitutions and some stick entirely to the phonetic ones. And these preferences can also contain information relevant to the author's background. For example, I live in the US. My life is clearly influenced by English. And if I were to type in Romanized Russian, I would express V as V. But I know some Russian-speaking people living in Germany, and they prefer to use W because that's more consistent with the German phonetics. And similarly, it can reveal some of the cultural background, like what other dominant languages are spoken in the area, in the community. For example, speakers of dialectal Arabic from former British colonies, like speakers of Egyptian Arabic, tend to more often Romanize the letter shin as sh, but speakers of Moroccan Arabic, whose language was influenced by the French colonists, are more likely to use ch. And this one might be a bit speculative, but I think some substitution choices can be correlated with age. For example, in the USSR, German was for a long time taught in schools more commonly than English, and German phonetics influenced early Romanization conventions for Russian. But with the rise of the dominance of English, the conventions changed, and now both standards are used, but it seems to me that the English one is more popular with my generation. And this by itself is a very interesting thing to study, I think. We could look at how Romanization varies across communities and how it changes over time under the influence of social factors. But also, if we can somehow de-anonymize the user by their preferences, or even just tell which anonymous texts have been written by the same person, this might be a privacy risk. So maybe we want to work on obscuring such attributes. And finally, I wanted to share a few final thoughts. And first of all, as I said several times already, typology matters for this kind of cross-lingual research. We need to be careful about the differences between the languages we're working with. And these differences can be subtle, and they can extend to seemingly mathematical or technical parts of our work. Second, occasionally rules can be better than data. In NLP, we're used to thinking that data is more useful. And if you have a native speaker annotator, it's easier and it's more useful to ask them to label some examples than to try and get them to write out the entire grammar. But in a task like this, the rules are actually clear and consistent enough that someone can hand design a very simple rule-based decoder, and it will outperform our supervised model, as we saw in the case for Russian. So maybe for some tasks, if you have a native speaker, it is actually useful to ask them to write down the rules instead of getting them to annotate data. And finally, I wanted to mention again that any normalization is lossy. If you standardize creative language, you lose the extra meaning that is encoded in the creative part. And it's not always clear what this meaning is and what the author intended to convey. So ideally, you want to have the author in the loop for annotation of such creative data. But also we could work on the kinds of normalization that are non-destructive. So we could maybe try to separately preserve the social meaning in sort of separately from the literal abstract meaning. And that's all I wanted to say today. Thank you very much for watching. And I wanted to mention that I have a list of references here as well, and you'll be able to find it in the slides when they're uploaded to the website. Thank you.